Assalamualaikum warahmatullahi wabarakatuh. My name is Aizat Farhan bin Muhammad Haris.
My name is Nur Atika Nabila Abdi Syamsul.
My name is Siti Nur Aiman Wajiha binti Syari.
My name is Nur Akilah Aliah binti Ruslan.
My name is Siti Nur Aslinda binti Hasan.
My name is Nazifa binti Rozali.
Let's look at our problem statement. Knowledge is an important component for an individual's life, especially in this advanced technology phase of the world. To gain knowledge, individuals can further their studies in the fields mostly based on their dream occupation. Every field of courses have different lengths of years of education. The more years that individuals spend on education, the more experiences they gain to improve their personality, cognitive skills, and also may gain interest in another type of occupation. Only the effects of years of education on an individual's cognitive skills would be focused in this study. Cognitive skills are very important as it helps individuals in solving, understanding, and analyzing problems. Thus, this study would like to know whether years of education can affect the cognitive skills of individuals.
Research question in this study is first, do cognitive score of vocabulary test, reading comprehension, sentence comprehension, mathematics, geometry and analytical reasoning can be explained by the years of education? Second, is there any difference between the main component of cognitive score for vocabulary test, reading comprehension, sentence comprehension, mathematics, geometry and analytical reasoning? Objective of this study is first, to see whether cognitive score of vocabulary test, reading comprehension, sentence comprehension, mathematics, geometry and analytical reasoning can be explained by the years of education. Second is to determine whether there is any difference between the main components of cognitive score for vocabulary test, reading comprehension, sentence comprehension, mathematics, geometry and analytical reasoning.
In methodology, several steps will be done in order to analyze the data. The data is first collected from the website since we are using a secondary data. After that, the data will go through the pre-processing process in which all of the unused variables will be removed from the model. Next is a model assumption checking to see whether MANOVA is suitable to be used or not. After all of the assumptions are met, we will proceed with the MANOVA. Using the MANOVA, we will check which means significantly differ from each other, and lastly is the interpretation of the results. The first step is the data collection. For the source of data, the original title for this dataset is interest. It contains the score of cognitive, personality, and vocational interests of an individual. It is obtained from a website called Carry, which contains a lot of multivariate statistics data, and the link is provided in the slide. For the sample size, this study contains a total of 250 data. And for the variables of the data, the original dataset has 3 independent variables and 30 dependent variables. For the independent variables, there are gender, years of education and age, with gender and years of education being a qualitative variable, while the age is a quantitative variable. For the dependent variable, there are 6 cognitive scores, 6 personality scores, and 18 vocational interest scores of an individual, with all of them being a quantitative variables.
Let's proceed with data preprocessing. Since this study wants to know the effects of years of education on cognitive skills, several unrelated variables have been dropped. The variables used are years of education as independent variable, cognitive scores, which are vocabulary tests, reading comprehension, sentence comprehension, mathematics, geometry, and analytical reasoning as dependent variables. Next is assumption testing. To perform a MANOVA, there are several assumptions that need to be met. First, variables level of measurement. Independent variables must be categorical variables, while the dependent variables are assumed to be continuous variables. Next assumption is normality. The dataset should have a multivariate normal distribution. This assumption can be tested by plotting a Mahalanobis distance against chi-square plot. If the points lie around the 45-degree line, then it is assumed that the data has a multivariate normal distribution. Another assumption is homogeneity of variance. The variance is assumed to be equal. This can be tested by using Levene's test to check the equality of variance and box M test to check the equality of covariance. If the test statistic of these two tests are more than alpha value, which is 0.05, then it can be concluded that the variance between independent variable groups are equal.
Application of assigned multivariate method. First, what is multivariate analysis method? We use multivariate analysis method to analyze the joint behavior or interaction effect between the variables. For this project, we apply MANOVA method to achieve our research objectives. Besides, we only proceed to MANOVA method if all assumptions are met. In this MANOVA method, we use three types of tests. First, multivariate test. Second, test of between subjects effect. And third, multiple comparisons test. We use MANOVA method to calculate the variation and effect of each and whole interaction of all independent variables. First test is multivariate test. Multivariate tests have four different approaches to compute F value for independent. That is Pillai's trace, Wick's lambda, Hoteling's trace, and Roy's largest root. Multivariate test, or the table of MANOVA F values, which calculate F value for independent variables in the mode, are used to see the significance of independent variables which contribute to the model. Pillai's trace have positive valued statistic which when increases in value means effect is contributing more to the model, while Wick's lambda means positive value statistic which decrease in means effect contributing more to the model. Hoteling's trace is sum of the eigenvalues. Roy's largest root is largest eigenvalue, which both of them with increases with positive value statistic, which increasing in value mean effect is contributing more to the model. Then in this project, we refer to Wick's lambda test. If p-value of the test less than alpha 0.05, we conclude there were at least one pair of means that is different. Next is test of between subjects effect. It is an extension of the analysis of variance in which each and whole term of the model were tested by their ability of variation within dependent variables. If the significant value of each intercept less than alpha 0.05 indicates that there is a significant effect of independent variables towards dependent variables. It is also can be interpreted by observing the observed power of the intercept. Observed power is interpreted as the medium to determine how correctly the intercept is rejecting null hypothesis, and it can be fixed by expanding the number of sample size. Observed power will be interpreted along with a non-centrality parameter, where it will compute the observed power in a situation where the null hypothesis is not true. Last but not least is multiple comparisons. Multiple comparison is used if the result from the intercept before is statistically significant. Then simple math effects used instead of math effects, because if we use math effect, it may misleading the result. Post hoc multiple comparison observe to compare the different levels of dependent variables with independent variables. And most commonly used post hoc is in interpreting Simpleman effects was to key. If the p-value is less than alpha 0.05, then there are statistically significant different means between all dependent variables with each independent variable. Hence, it concludes all the methodology that we use on our project. Next, we will move to the result and analysis of our project.
Results and discussion will start off with the chi-square plot. From the Mahalanobis versus chi-square plot shows that the data of the study have multivariate normal distribution. This chi-square plot is used to evaluate whether the data observed have a multivariate normal distribution or not. This plot has multivariate normal distribution since most of the points scattered seem to be in a straight line on a 45-degree line. Here in the plot also see that there is one outlier point at the end of the plot tail.
Here is the descriptive statistics of the data. Firstly, there are 11 respondents with 8 years of education and 14 respondents for both 14 years and 16 years of education. 205 of participants have 12 years of education, while the least category is 18 years of education with only 6 participants. The vocabulary test has a mean of 0.0902 with standard deviation 0.99832. Besides, the mean and standard deviation for reading comprehension is 0.1350 and 0.99053 respectively. Next, the sentence completion has mean number of 0.0736 and standard deviation of 0.99167, while the mean for mathematics is 0.1055 with 1.05439 as its standard deviation. Lastly, mean for both geometry and analytical reasoning produced 0.1125 and 0.1750 respectively, with 1.03376 and 1.05693 as its standard deviation.
As for the box sum test, it's used to check the various covariant matrices, where it is commonly used to test the assumption of homogeneity of covariance in MANOVA. For this study, the H0 is covariance 1 equals to covariance 2 equals to covariance 3 equals to covariance 4 and equals to covariance 5. And for the H1 is at least one covariance matrices are not equal with alpha value of 0.05. From the results in the box M has value of 93.371 and the P or significant value is 0.143, which is significant value is more than a value which is more than 0.05, and hence we cannot reject the H0 and we can conclude that the covariant matrices are equal. For the multivariate test, it is a technique for testing hypotheses in which multiple variables for this test. It is to determine which combination of variation perform the best out of all the possible combined combinations. And then for this study, the H0 is mu1 equals to mu2 equals to mu3 equals to mu4 and equals to mu5. And for the H1 is at least one pair of means is different with 0.05 the value of alpha. And here in the result, we will focus on the second column labeled EDUC and find the width lambda value. It is stated that the result that the width lambda value is 4.735 and the significant of p value is 0.000. And from the value on the result, we can conclude that the decision is to reject H0. And since the significant value is less than the alpha value, it can be indicate that at least one pair of mean is different.
11 tests of equality of error variance in this study. If the significant column in the table is less than 0.05, we will reject H0. In conclusion, the population variance of vocabulary test, reading comprehension, sentence completion, mathematics and analytical reasoning are equal because the p-value is greater than alpha. While the population variance of mathematics are not equal because the p-value is less than 0.05. Test of between subject effect. There are many rows in the table of test of between subject effect, but we will only look at the education row. If the significant value in this education row is less than 0.05, it tells that the education had a significant effect on the result of dependent variable. Since all the significant value is less than 0.05, it shows that the education in year 8, 12, 14, 16 and 18 had a significant effect on the result of vocabulary test, reading comprehension, sentence completion, mathematics, geometry and analytical reasoning. We can conclude that there is statistically significant difference in mean cognitive skill between 8, 12, 14, 16 and 18th year of education. Last, we will look at the multiple comparison table. If the significant value is less than 0.05, we will conclude that there is significantly difference. If the significant value is greater than 0.05, it means it is not significantly different. It shows that vocabulary test, reading comprehension, sentence comprehension, mathematics, and analytical reasoning has the same result. We can conclude that the education in years 8 is significantly different from years 12, 14, 16, 18. Education in years 12 is significantly different from years 14, 16, 18, while education in years 14 is not significantly different from 16 and 18. Last, education in years 16 is not significantly different from years 18. For geometry, we can conclude that the education in years 8 is significantly different from years 12, 14, 16 and 18. Education in year 12 is significantly different from years 16 and 18, while education in years 12 is not significantly different from years 14. Education in years 14 is not significantly different from years 16 and 18. Education in years 16 also is not significantly different from years 18.
Lastly is conclusion and recommendation. For normality testing, our data is normally distributed since most of the points lie on the 45 degree of line. The box M-test also shows that covariance matrix is equal since the p-value is less than 0.05. Thus, we conclude that MANOVA is suitable to be applied for our data since all assumptions done above satisfies all the criteria. Our first objective is to see whether the years of education are useful in explaining the cognitive scores. We conclude that the years of education has a significant effect on an individual's cognitive scores since the p-value is less than 0.05. Our second objective is to see whether there is any difference between the main components. For reading comprehension, vocabulary test, sentence completion and mathematics, 8 and 12 years of education has significant different scores with the other year of education. But 14 years of education has no significant difference with 16 and 18 years of education. And there is no significant difference of scores between 16 and 18 years of education. Meanwhile, for geometry and analytical reasoning, 8 years of education has significant different scores from 12, 14, 16 and 18 years of education. 12 years of education has significant different score with 16 and 18 years of education for both cognitive. But the difference is that while 12 years of education has significant different score with 14 years of education, geometry has no significant difference between them. Lastly, 16 years of education has no significant difference with 18 years of education. So in future study, we will try to consider testing for effects of other independent variables towards an individual's cognitive skills. such as their age, gender, and race. So that's all from our group. Thank you.